So, Shilpi, are you ready for the next speaker?
I am. I definitely am. And the talk title is really interesting. So we have had a speaker change. So we do have a really exciting talk, actually. So we do have Randall who'll be joining us very soon. And I'm looking forward to the talk. Obviously, it has a very interesting title, 12 Factors of Pain and Suffering. So that in itself, like, kind of definitely excites me as well. And from what I understand, we're going to be learning from his experiences, and he wants other people to sort of gain knowledge from that as well. So we'll bring Randall on, and he can tell us a little bit about what he'll be speaking as well. Hey, Randall.
Hey, what's up, Shilpi? Hey, Vandana. So cool to see you all again, since we were just hanging out in person a few days ago. So that's pretty neat.
I know, we were just talking about it, like we were all in the same city, and now we're all like literally across the globe and fighting different time zones and trying to sort of stay awake. And Randall's living the hacker life, staying awake late at night. What time is it at your end?
It's only 10 p.m., so it's not that bad. But I'm in California, and so we are, I think, literally on the opposite sides of the earth from each other right now. But that's what's so damn cool about the internet. You get to like make friends and hang out with people in person and around the world. It's the best. So
yeah, totally agree with you. Totally agree with you. And thanks for jumping on at the last minute. So that's really amazing. Thank you. And before we start the session, we do want to know about just a snippet about what this talk is going to be all about.
Okay, I will tell you. So I wrote this talk a couple of years ago. So it's about 2 years old, maybe. And at the time, so I've been writing code for pretty much my whole life. So I got started when I was 12 years old. I've been writing code for over 21 years now, which tells you about how old I am. I'm pretty old at this point. But it's been like my entire life's passion. And through that time, I've gone from being a complete noob when I was a kid to nowadays, after writing code for 21 years, still being a considerable noob. And so not that much has changed. And I would say that one of the things that, when I'm talking to new developers and people that are sort of getting into the space, they always have this like idea that like, as you practice and get better and better and better, you make less and less mistakes. And I don't think that's true. Like I screw things up literally all the time. I'll be the first person to admit it, And I thought it'd be fun to talk about the 12-factor application, which is a series of these 12 best practices for building scalable, dependable web applications. But instead of just talking about like, here's the principles, here's how to do things the right way, I thought it'd be more fun to tell you about 12 ways I've actually screwed up each of those things over the years. And so that's what this is, a series of my 12 personal factors of pain and suffering that have screwed me up for a long time.
That sounds amazing, and I'm really looking forward to it. And as you said, it's quite well put. Like we can all learn from each other, and it's so good of you to actually share this with the community. So I think, without further ado, we might just throw to you, and let's hear about these 12 factors.
Let's do it. Let me know when you got the slides live and everything looks okay.
We're looking good.
All yours.
All right, cool. So as Shilpi and Vandana said, this talk is called the 12 Factors of Pain and Suffering. And really, it's just a list of my own sad programming stories. So feel free to drop some comments in the chat. I'll do my best to answer them afterwards, or you can always tweet at me. But these are real, actual things that have happened to me. None of this is exaggerated. These are like the story of my life, basically. So real quick about me. So I'm Randall. I work in DevRel and community at Sneak. So it is amazing to meet all of you here today. And a couple of things you should know. So I'm a Python, JavaScript, and Golang hacker. These are sort of like the three primary programming languages I work in nowadays. In the past, I did a lot of lower level operating system development stuff, but this is sort of what I work on nowadays. I've also been doing open source like my entire life. So I love open source. I'm an author, so I write a lot of technical articles, security stuff, programming pieces, etc. But most importantly, I would say that like I associate with being a builder. I just really love to build things. And I think because of that, I've had the sort of good fortune to work on just a ridiculous amount of weird, unique, interesting projects over the years, some of which I will share with you tonight. So first of all, what is the 12-factor app? Well, if you haven't heard of it before, it's a methodology for building simple, scalable, and dependable web apps at the end of the day. It was created by Adam Wiggins. So he was one of the founders of Heroku, with like the app hosting platform. And if you want to learn more about this, you can go to the website. It's 12factor.net, like the number 12, then the word factor.net. It is one of my favorite websites of all time because it's really simple. It's really like just dependable, and it lays out these principles in a really crystal clear way that I am going to do a huge disservice to tonight, I'm sure. But as I said when I got started, the reason I thought it'd be fun to share all this stuff is because as an experienced developer, I've screwed things up a lot in my career and a lot before I even had a career. As a matter of fact, I still screw things up constantly today. And so, these are just fun stories to teach you some of these principles. All right, so let's get right into it. Principle number 1, code base. So when you're working on a project, generally speaking, you always want to have one code base that's tracked in version control that you deploy many times. So what does this mean? Well, let's say you have a project, right? You would take that exact same code base and you deploy to like a production environment, a staging environment, maybe a local development environment or multiple local development environments. But the important thing to note is that it's one code base that you just deploy to these different environments. And this is sort of a best practice for dealing with a code base. I think we can all sort of agree upon this. You look at it, it looks pretty straightforward. So you're probably wondering, how did you screw this up? Well, back in the day, this was in maybe 2009, I had started a website with a couple friends of mine, and it was like becoming a full-time business. And basically the way the website worked is if people would Google a phone number online, they would land on our website. So we were the #1 ranked website on Google search. And we would basically say like, hey, click here for more information about this phone number. People would click through to our webpage and they would see a bunch of information about the person that owns this phone number. Like this is a person, they live at, this area. They're not a spam bot, just basic information, maybe their cell phone provider or whatever. And what we would do is we would sell affiliate links for basically these visitors to get more information about a person given their phone number. And that's how we'd make money. And we would make something like $50 per affiliate sale. So it was a lot of money coming in from this website. Now, this was all running extremely well, and we were getting paid a lot of money until Google released their Panda search algorithm update. Now, I believe this was back in, I want to say 2009, 2010. But when Google released this major like search algorithm update, it completely destroyed our business overnight. So our entire website, it was tnid.us, got completely delisted from Google. And so we showed up in no search results at all. And so we went from making like a lot of money every day to making like $0 a day. And it freaked us out. So I was actually on my first vacation in like 2 years, I think, when this happened. And it was so annoying because the entire vacation I worked on this. But basically what I did is I said, okay, well, we have 2 things we have to do. First of all, we have to like figure out how to contact someone at Google and like figure out how to get our website unbanned. There must have been some issue on their end and like we'll sort it out. In the meantime, though, what I'm going to do is I'm just going to go ahead. I'm going to copy and paste the code base for the existing site, tnid.us. I'm going to purchase a new sketchy domain name for this thing. I'm going to make a new logo. I'm going to like rewrite the wording on the homepage. I'm going to change this color scheme. And I'm just literally going to relaunch like the same code base with these minor changes under this new domain name and hope that this new domain name is going to get picked up and indexed by Google over the next few days so we can still have some revenue coming in. So that's what I did. And this took me, I don't know, like 8 hours or so of work, something like this. I got everything live and I sat back and I was like obsessively checking, Google Webmaster Tools to see if our website had gotten picked up. Well, the next day, things started working a little bit. We started to see some traffic. We started to get indexed on Google. And after a few days, things were starting to run pretty well on this new domain. And so I thought, maybe we're going to be okay after all. But then this new domain got banned. And so then what I did is I freaked out again. And I said, okay, I got to keep the original domain running and this domain in case this gets unbanned. And I'm going to create a couple additional domains. So I copy and pasted the code base again into 2 different iterations. I bought 2 more domain names. And then I went through the painstaking process of like changing all the logos, the color schemes, the name, and all these things. And these websites also both got picked up by Google, but then shortly banned a little while afterwards. And so I was basically in like this massive copy paste cycle for about a month and a half where I was essentially trying to outsmart Google. And what I would do is every day I would work insane hours and I would literally copy and paste my old code base, buy a new sketchy domain name, run some code I'd written to like spit out new logos and images, and then like alternate color schemes and do all these things to like try to trick Google into thinking that like these are different websites. And over time, as you can imagine, this method slowly stopped working altogether. And so this allowed us to continue on for another month and a half or so, but it was brutal. Now, the worst part about this, and the reason why it was so brutal, is because every time I did that, I was maintaining now 20 different copies of this same code base. And I was literally, every time we had to make a change, going into all 20 versions of this code base and editing things in order to make this happen. What I should have done if I was smart, which would have saved me a ridiculous amount of time, is I should have templatized all the things in a single code base and just deployed it to these different environments. And so I know that this isn't really the exact perfect scenario described by the 12-factor application, but I think it's super relevant. And so the lesson learned for me is follow the code-based rules and you will not feel as much pain as I felt. All right, second factor is all about dependencies. So whenever you're building an application, you always want to explicitly declare and isolate your dependencies. Now, again, this sounds super simple, makes sense, right? So again, how did I screw this up? Well, here's how it works. First of all, when you declare dependencies, like let's say you're building a JavaScript application, you're going to have like a package.json or something like this, and you're going to specifically write out all your dependencies that you need to build your application. And then when you isolate them, you're essentially saying, I'm going to go install these things, which is going to take all the things that I've written down and build a little environment so I can run my application. And again, this all makes sense. Now, the way I messed this up was years ago, I was building an image optimization API service. And the way this worked is that if you were a user, you could essentially send my service this image, whatever image you had, like this really super cool image of a crow holding a knife, which I thought was awesome. And you take this image, you send it over to the image optimization API service. What I would then do is I would say, okay, let me go ahead and optimize this image for you. So then I would send back the optimized version of the image to the user, and it'd be a smaller file size, but quality would be the same. And so the user would be happy. Well, on the back end, the way this worked is this was all running on a VPS. So on this VPS server, this was just a single server, service. I had installed a bunch of these command line image optimization tools. So there were things like OptiPNG, JPEG Optim, GIF-Sickle. There was a few others I don't remember. But basically, the way things worked is every time an image, would be sent to the service, I would literally shell out to one of these command line tools to optimize the image, take the resulting image, and then send it back to the user. Now, this service was working absolutely great. I put it online. It was an open source GitHub project I wrote. I put it online, and over time, it started to get some a sizable amount of free users. And what ended up happening is one day I started having all of these, service notifications from my provider saying like, hey, you're going over your usage limits. Your VPS server is like running out of memory. And so I thought, oh, cool. I took a look at the traffic. I saw I needed to scale it up. And I thought, all right, what I'm going to do is I'm going to literally create a second VPS server, put a load balancer in front of both of these things so that I can then, just route traffic between both of these things. And I literally took my JavaScript code base, I copied it over onto the second VPS server, I ran my npm install, and then I updated the load balancer and thought everything would be fine. Unfortunately, things were not fine. And the reason things weren't fine is because, of course, on my second VPS server, I didn't have any of these command line applications installed that my application needed in order to run. Yes, I had all of my JavaScript dependencies, my web app dependencies, all of those things, but I hadn't fully considered the entire spectrum of dependencies that my app needs. Now, at the time, if Docker had existed, it would have made this problem like moot because I could have packaged everything up, including like my code, all the command line tools, all these things into a Docker image. But this really goes to show you that when you're thinking about dependencies for an application, you have to think about it holistically. You can't think like, oh yeah, it's just this one little part of things over here, over there. You really have to think about it in the terms of the big picture. And so that's how I screwed that one up. So next, let's talk about configuration. So the 12-factor app states that you always want to store configuration data in the environment, aka environment variables. Now, if you think about sensitive things that you're going to update from time to time in your applications, you might have things like a database URL, a price for something, max number of threads you want to run for like a given, application server, or API credentials, right? Now, the way I messed this one up is back in the day, I was doing a lot of telephony work in my earlier jobs that I had. This was around 2009, 2010, 11, 12, things like this. And a lot of the work that I did was based on top of this open source Linux software called Asterisk. Now, if you haven't heard of it, it's really cool. It essentially lets you write code to program like phone calls, SMS messages, things like that, and just makes it super easy for you. And at the time, I just started scaling up this free teleconferencing software that I was working on, and I was trying to deploy it to like a really hot cloud provider at the time, aka Rackspace. And this was before things like Terraform existed, And so I was trying to write some bootstrapping code, which would essentially take all the code that I wrote, deploy it to a cloud server or to a new cloud server, and then set everything up for me. And so what I did is I manually provisioned a Rackspace API key, and I wrote some code that basically took my Rackspace API key and used it to provision a server and copy over all of my Asterisk stuff onto the server, run all the setup commands, etc. Now, I was working on this and I decided, hey, you know what? I'm trying to test this out to see if it works. So what I'm going to do is I think I was running like Hudson or Jenkins at the time, a CI system. And what I wanted to do is I wanted that CI process to basically kick off this bootstrapping procedure. And so I was like in the testing and development phase of this. This was all open source. And I thought, you know what? I'm just going to go ahead and hard code my Rackspace API key directly into my open source code base on GitHub, just for a little while, just to see if my CI system will pick it up, run all the things necessary, and actually do the bootstrapping. Now, I knew at the time this was a terrible idea because like I was putting my sensitive API key public on the internet. But I thought, you know, it doesn't really matter. Like no one's going to be looking at this thing, whatever. And so I went ahead and pushed it live and I tested things out. Things worked absolutely great. I didn't notice any issues. And so I went to sleep. Well, as soon as I go to sleep, this is what happened, I presume. Some jerk out there was running a bot that was looking for noobs that were uploading their sensitive Rackspace credentials to GitHub, like me. So they scraped my API credential and immediately started making requests from using my API key to Rackspace and basically provisioning these massive servers that they would then run as Tor relays. And so that takes a ridiculous amount of bandwidth. So I woke up in the morning and completely freaked out because I saw all of these billing emails from Rackspace. And when I took a look at it, I noticed that I had a negative $25,000 account balance. And Rackspace at the time had actually tried to bill my personal credit card hooked up to my Rackspace account. And it failed because my personal credit limit was like $2,000 or something at the time. And so, of course, I had like absolutely no money to pay for something like this. And so this scenario was absolutely terrible. Now, thankfully, I eventually figured out what had happened. I contacted Rackspace support and they were absolutely amazing. They were like, look, it happens all the time. Don't worry about it. We're going to like reset your billing stuff. So they were amazing. But the lesson learned is don't be lazy. And in a lot of cases, even when you know better, like I did, you're sometimes still lazy. You sometimes still do the wrong thing. And this is just a reminder that that can be very costly. So, you know, try to store your config data in a good place like the environment, or maybe in like a secure environment storage like tool, like HashiCorp has some options there. But this is sort of the lesson learned. All right, next, let's talk about backing services. Backing services. So what are they? Well, basically, you have a production deployment somewhere, and you have all these services that your production application relies on. So maybe if you're sending emails, you might rely on an SMTP service. Or maybe if you're deploying or storing files in a bucket system like Amazon S3, you're going to need like the Amazon S3 deployment URL somewhere. Or if you're talking to a database, you might need the database URL to connect to it. And the 12-factor app states that whenever you have these like backing services, you want them to act as like attachable resources. And what that means is you should be able to easily just update this one URL here and instantly have your production environment switch from one Postgres database to another. So you should have these things just be easy to add and remove. That's really all it means. Now, this here is a self-image of me that I drew of myself as a really young programmer. I was super happy. I had great ideas. I was really, positive about everything. And I was maybe 12, 13 years old, something like that. And I thought, you know what? I'm an amazing programmer and people need to know about this. So I need to make a blog. So I started my first blog on the internet. And I was really excited. I used to write on there all the time about things I was building and research and stuff like this. And it was pretty exciting. And this was a blog that I built custom myself, of course, in PHP and used MySQL. And I ran it on a shared web hosting service, one of those cheap ones back in the day. And when I went to college, I was a really shy, nerdy, introverted kid. I didn't really know how to make friends. And so I thought, you know what's going to make me some friends is if I give out pirated movies to everyone at school. Now, I went to college, or I got out of high school in 2006. So like, I think I went to college in 2006 or 2007. I don't really remember. But this was like a super cool thing at the time because like piracy was like all the rage. It sort of still is, but hence the flag back there. But I thought, hey, this is going to be really fun. I'll make some friends. I'll be like the cool person on campus. And so what we did is my roommates and I ordered the Netflix 4 DVD per week subscription service. So we would order 4 DVDs a week. They'd come in the mail. I would rip them myself. I would upload them onto my shared web hosting provider, and I would just hand the link out to all my friends at school. And this worked. So I made some great friends and met some really cool people. It was super awesome. Until one day I run out of disk space on my shared web host. And so at this point in time, my blog, I'd been working on it for maybe 7, 8 years at this point. And I thought, hey, I've learned a lot. I know that I can scale this thing now and make it way better, properly architect the entire thing. And so I decided the first thing I'm going to do is I'm going to take these, this massive blog, which is consisting of hundreds of these PHP files just strewn all about the var dub folder. And I'm going to rewrite it so that instead of using the free local version of MySQL installed on the shared web host, I'm going to create a separate independent MySQL database server. I'm going to move all my logic into there. And then I'm eventually going to create a separate file server to host all the movies and then just architect the thing properly. So the first thing I did is I provisioned this MySQL server, copied all my data over, and then I went to go integrate it back into all of my blog code. And what I realized is that this was actually ridiculously hard to do. And the reason it was so ridiculously hard to do is because in all of my PHP files, hundreds of them, by the way, I was just randomly connecting, using MySQL _connect and just not supplying any parameters because I was connecting to MySQL on localhost with no username or password on the default MySQL port. And so I had to actually go in and rewrite I think thousands of MySQL invocations all across this project. And it was a total nightmare. And so the lesson I learned here is whenever you're using attached resources, whether it's MySQL or, an S3 bucket or whatever, always treat them as attachable resources. Make sure you're storing these credentials in an environment variable ideally, and make sure that it's something you can easily swap out so that you're not relying on just thousands of lines of custom code like I was. And that's me being extremely annoyed when I realized how terrible of a programmer I was, by the way. All right, so next, build, release, run. You always want to strictly separate your build and run stages. So what does this mean? 1 second. There we go. So you have your code, and when you're going to get it ready, you have a build process. And ideally speaking, you want to have some configuration data, which is a package of your environment variables, configuration information, everything like that. And all of these things get created into what we would call a release. And the release would be the thing that actually goes live and does stuff in the real world. Well, I don't know if I mentioned this before, but I was sort of a script kiddie as a kid. I think you get the idea by now. And basically what happened is when I was working on my personal website on that shared web host back in the day, I had my website code on my computer. And I had my web server running live on the shared web host. And so whenever I'd work on the shared what I would do initially when I went to work on my website is I would write some code locally, then I would SCP it over to my live web server, then I'd refresh the page and test it out to see if my PHP code worked. Now this was fine, except as your project grows, this SCP command gets really, really slow because you're just copying tons of files over all the time and it just takes forever. And so what I said, you know what? I don't really need to do this anyways, whatever. I'm just going to SSH straight into my web server, modify my code files directly, and then test things out without all the delay. And then what I would do is after I would do that, it would, if once I got things working, I would then try to copy the working code back onto my computer. So I had a local copy of it. But then sometimes I would lose track of which one was doing which. And then I have to copy code from here onto there. And it was just a massive nightmare. And so it was bad. And it was really frustrating. And that's why you always want to separate those build, run, and release stages of software. If I had known that back then and followed those principles, I don't think I would have had such an annoying time. Now, unfortunately, by the way, everyone, I realize I am talking incredibly slowly here and telling these stories slowly. I apologize. I realize I have about 6 minutes left, so I'm going to probably finish one more of these, but I don't think we'll be able to get through all 12 of them, so I apologize. Now, going back to the story real fast, processes. The 6th factor in the 12-factor app talks about that you always want to execute your application as one or more stateless processes. So what does this mean? Well, the key here is stateless. So when I was building this conference calling service, this free conference calling service back in the day, I had this application. It was deployed in a data center, and I had multiple instances of this thing running. And the way it worked is these were all running on separate physical servers. And so I would basically have like this massive pool of phone numbers, and each of these phone numbers would be assigned to a different server. And in reality, there was like 100 phone numbers assigned to each server, but you get the idea. And what happened is, what was cool about this free conference app is that like you could set up a conference room and you could custom record your own voice prompts for it. You could customize the entire thing. And so people really enjoyed it. And what would happen is when people would call in and manage the custom voice prompts for their conference lines, each of the recordings they recorded would be stored on the server in which their phone number was assigned to. And so this was sort of the way I'd originally architected this application. Now, this worked pretty good until one day, one of these physical servers in a data center in Pennsylvania like completely went offline. And when that happened, my code worked. So my load balancer over here essentially rerouted all of the phone numbers that were going to this server to the other existing servers. But what happened is I got a lot of angry user complaints because people just said, hey, my conference number is working, but all of my custom voice prompts are gone. And what ended up happening after I did some debugging is I realized, well, when this server went down, the custom voice prompts that were on this server were not on these servers. And so this wasn't really a stateless process, like this was a very stateful process because each of the instances of this conference calling application essentially was very stateful and it was bound to a physical server. And so this is not something you want to do. Now, let's talk about port binding real fast. I was just told by one of the hosts, by the way, that I am allowed to go over because there is a break. So I apologize, but you know what? This is Zoom or it is virtual, excuse me. And so you could always just take a break and watch this if you want. Now moving on, port binding. So the 12-factor app states you always want to expose services you're building, web services, via port binding. Now this isn't as relevant today because things have changed so much and people are using a lot fancier systems that this is sort of like dated information. But regardless, I think it still rings true, especially if you're talking about deploying things in a manual way. Now, back in the day when people build web applications, they would bind them to port 80 or port 443, things like this to have, TLS. But this is just a really bad thing to do. Essentially, what the 12-factor app states is that when you're doing things this way, you're shackling yourself to a very particular port. And instead, you really want to let your routing layer of your application, whether that's your Elastic Load Balancer or like, your Kubernetes cluster that's managing things, you really want that to be able to assign your application ports for you dynamically. This way you can run as many instances of these applications as you need to in order to scale things out horizontally. Next, concurrency. So the 12-factor app states that you always want to allow your application to scale via the process model. So what does this mean? Well, imagine you have a web application and you have a couple different instances of your web server. So you have web 1 and web 2. These are two web applications, two web processes, if you will, that are both receiving incoming requests via a load balancer. Now, you also might have different types of processes. So maybe you have a web application process, but you also have worker applications running behind the scenes. And you should be able to dynamically add and remove these processes in order to scale your application as needed. You might also have other types of processes, et cetera, but you get the idea, right? You should be able to dynamically just add more things when you need more capacity and remove things when you need less capacity. Now, my story here goes way, way, way back. Like one of the first big projects I ever built as a kid was I built I thought it was super cool, by the way. I thought this application was like super next level at the time, but I used to go on IRC all the time. That's how I met friends and learned about programming and things. And I built an IRC web application that would let you just join IRC from a browser and interact with people in the chat rooms. And at the time, like, I don't think this had been done. I might be wrong, but this was like a really long time ago. And I thought it was like super amazing. So I built this application. I shared it with some of my friends on IRC and people really liked it. And so I decided I was going to scale this thing up, turn it into like a proper business and just like, be like the next, internet celebrity basically. But the way this application worked was the web app would literally allow you to join different IRC rooms. And in order to scale this thing, I was writing this entire thing in C, by the way. I decided to run the entire application as a Linux system daemon. And so it would basically run this massive master process that the operating system would boot up, and it would fork itself off into a bunch of child processes, one for each IRC chat room that people would join. This worked pretty well, but as I got a few of my friends using the service, I noticed that like over time, what would happen is one of the processes would eventually die for whatever reason, and then that would cascade, and that failure would eventually kill the daemon, which would then restart the entire process. And so therefore, all of the child processes would die, and that would therefore disconnect people from IRC and kick them off the network so they lose some chat history before eventually reconnecting. And so it was a huge pain. Now, I worked on this application a lot. Like I put, hundreds, maybe even 1,000+ hours into this thing, and I was never able to completely solve these problems. And that's because doing interprocess communication in C is really hard, especially if you're like, a 13-year-old kid and you're not that knowledgeable. But regardless, I think that if I had known about the 12-factor app back then, and I could, better think through this in my mind, what I would have said to myself is, hey, instead of building this one massive application daemon that is doing its own, multi-processing and all this work, why not just have each process be its own stateless, small, contained thing? And why don't I just make a way for it to, for me to be able to add processes horizontally and not have this one amalgamation that's sort of doing everything? I think that would have dramatically simplified the types of problems I was solving. And maybe today I would have a really cool, business or story about a successful IRC web application, is that one that just sort of failed and sort of fell into obscurity. So next, the 9th factor in the 12-factor app, we're almost there, is about disposability. And the rule here is that you want to maximize the robustness of your app with fast startup and graceful shutdown. So you always want your application to shut down gracefully when a SIG term is received. You also always want to shut down within a few seconds. You don't want to let things linger. And finally, you want to be really robust against sudden death. So even if your application is killed with no warning whatsoever, like kill-9, it should still, be able to spin back up and handle whatever things it was in the middle of doing without causing any sort of weird side effects. Now, going back to that free conference calling app I told you about earlier, at this point in time, I was starting to scale it up and things were getting a little more successful. And so we had requests coming into a load balancer. The load balancer was basically dynamically scaling up and adding various processes to essentially handle more and more calls as they would come in through different times of the day. But I was running into issues with my auto scaling code because as I would add new processes, I would realize that like I would start them up, and then after about 30 seconds or so, they would like fail and then just restart indefinitely in an indefinite loop. And as I was debugging this auto scaling software that I'd written, it actually took me quite a while to figure this out. Eventually, what I learned is that, and by the way, this is all written in Python, and this is like pretty accurate. Like this is pseudocode, but it's pretty accurate to what I remember the actual code was like. But essentially, what I realized the issue is I had this startup routine. And so the process would start up, and the first thing it would do is run this download audio function. And this would essentially go off to like a Rackspace file server and download all of the MP3 files for all the custom audio prompt recordings for all of the conference lines assigned to this particular process. And once those things had been downloaded, it would then bind itself to the appropriate port. Everything would be running, and the process would start accepting new incoming calls. And so this like worked okay in test environments, but when I ran it in the real world, it would cause this behavior here. Well, what I later came to realize is that this was actually the issue. Running the download audio thing when the process started up was causing problems because when my auto scaling software would boot up one of these sub processes, it would then go and attempt to download something like, 700 gigabytes of audio files. And that takes a lot more than 30 seconds to finish. And so what would happen is I would download every audio file, not just the ones for the particular conference numbers I needed to. And so therefore, this process would take longer than 30 seconds to complete. The process would never actually bind itself to the port. And so the autoscaler thought that because it never bound itself to the port, the process had failed, and so it would kill and restart it. Now, this goes back to those 12-factor application principles, because had I sort of followed those rules about having a really fast startup time, really fast being able to recover from shutdowns in a graceful way, this wouldn't have been an issue, and I wouldn't have had to do all this debugging. So just a reminder that these things do make a huge difference in the real world, and it's great to keep them in the back of your mind. All right, next, dev prod parity. So you always want to keep your development, staging, and production environments as similar as possible. This one's super important. This is something I've done. By the way, I'd like to admit that I've learned this lesson, but I literally do this all the time because it is so convenient, and it's sort of, I don't know. I'm a bad person, I guess. But basically, let's say I have some code running in production, and that code is being deployed to Postgres in the real world. I love Postgres, awesome database. Well, a lot of the times when I'm working on things in development, instead of using Postgres, I'll use like a SQLite database instead. That way I don't need to actually run a Postgres process or have a fancy development environment somewhere remote. I just literally run things locally. It's super fast and easy. But this has bitten me way more times than I would care to admit because of things like database compatibility issues. Like for example, did you know that if you're using SQLite and you define a varchar and you give it like a particular length, that SQLite actually completely ignores it and will allow you to store any length of varchar inside of that item. And so that becomes an issue because maybe something in your test environment when you test with SQLite that works, when you go to production will break. And this exact thing has literally happened to me a handful of times just from the ones that I can remember. And, like I said, I still do this today. So I'm embarrassed to admit. But if I were the type of person that really wanted to do this properly, what I would do is make sure that my development and production environments were basically identical. Like if you're using Postgres in production, use it in development too. Make sure you have things as similar as possible to the real world scenario. That way you minimize the risk of stupid things like this happening to you. All right, next, logs. You always want to treat logs as event streams. So imagine you have an application that generates a bunch of logs. Well, the rules are A, you always want to store your logs ordered by timestamp. B, you always want to write your logs to standard output. And C, you want your logs to consist of all of your process and backing services. That way, if anything ever happens, you can always go in and reconstruct log-based information to figure out what went wrong, right? Now, again, this all makes tons of sense. Now, this one in particular is something I screwed up that actually cost me a lot of money, so pay close attention. That free conference calling app I told you about before, I sort of previously described the telco infrastructure. Now I'm going to describe the web application side of it. So I had this web app that people could go to get one of these free conference calling numbers, set it up, record voice prompts, and do all this stuff. And that web app talked to an API server I had that was built in Python. And all of my Astra servers, which were running in an actual data center, whenever a call would come in, essentially, they would then send, an API request to the API server. The API server would basically like write an entry into a literal CSV file called calls.csv. And that CSV file would essentially have like the phone number that called, and then the number it was calling to, like which conference number it called to, and then the duration, like the start and stop time of the call, and then a bunch of other metadata. But those were really important pieces of information because this information is what we use at our company to get paid. So what I would do is at the end of the month, I would literally run an SCP command, and I would essentially copy this massive calls.csv file from the root of this API server onto my local laptop. Then I would send it to the telco. They would literally add up all the billable minutes and then pay us a certain amount of money for how many billable minutes we used on the service. And so that's literally how we got paid. Now, one day I was doing this and I noticed something was wrong right away. I ran this command. I was trying to check to see, it was about halfway through the month. I was trying to check to see where we were at and what our business projections were going to look like. And the command completed super fast. And I was like, that is so weird. This always takes forever. And so I was looking into it, and I was looking into what I did, and I realized, oh my God, I ran the SCP command, the same one I always do, except I reversed the arguments. I put SCP dot root at, IP address calls.csv. So what I had done is I'd copied the empty version of the calls.csv file from my local laptop over onto the production server, completely overwriting the original calls.csv file that contained the accurate count of our billable minutes for the month. Now, what I should have been doing at the time, which I was not doing, is I should have been taking the logs from each of these independent services and dumping them all into some sort of log router. It could have been into a service like Sumo Logic or Loggly or literally, LogDNA, anything. That this way I could have gone in and actually taken a look and reconstructed these calls. Unfortunately, I did not do that. I specifically disabled logging and only use this system. The reason why is because when I first built this, I started running out of disk space on these servers here because they were generating so many logs. And so I thought, I don't need them, screw them. And so I completely disabled them. But the end thing is that this cost me a lot of money because we completely lost account of all of our calls for about half a month. And that was, hundreds of thousands of dollars at the time. So yeah, this is a real world example of how logging can actually be detrimental to you if you don't do it sometimes. So final factor is admin processes. You always want to run your admin and management tasks as one-off processes. So what does this mean? Well, this is a real world thing I did. So I had to run a database migration on an application. And this was really simple. Basically, all I had to do was was modifying a database schema. And all I really had to do was run the command Python manage.py migrate. And this would basically take my database migration code, execute it against the database, and things would work just fine. Now, ideally, if you want to do this, what you would do is you would code this into like a task. You deploy that task to your infrastructure somewhere in production. Then you would fire off some production task to actually make this work. What I did instead was this. So I was working on a new feature one night, and I had to alter the table to add a new column to make this feature work. And so I wrote all my code. I wrote some database migration code, and I was ready to deploy this thing and get it running. And I basically said to myself, well, I only need to do this once, and I sort of want to get out of the office. Like, I've been here all day. So I'm just going to go ahead and do the database migration from my laptop instead of deploying it, like I said, into a separate code task and like having it run in production, all that stuff. And so on my laptop, I literally just ran Python manage.py migrate. The database migration was executed successfully, and I hit deploy to production. Let's get the new feature out there. So I do this and deploy the feature, and I start immediately getting calls from my boss, and he was saying, hey, the entire platform is down. And he was so mad. He's like, what were you doing? And so after doing some debugging later, what I realized I did is when I ran this Python manage.py migrate locally, I'd forgotten to update. So I was actually doing a migration against the SQLite local version of my database and not the production Postgres version of my database. And so this is just another reminder why you always want to keep these things running, even for simple management administrative tasks in official production infrastructure. You want it coded, tested, the whole 9 yards. So don't be lazy like me. So that's it. Those are the 12-factor application principles. I hope that was fun. If you want to check out some more of my stuff, you can always check it out here. Ignore these things. This is from a while ago, but my personal website is rdeggs.com. I also work at Sneak. It's an awesome company. So if you want to check it out, please go to sneak.io, SNYK.io. And yeah, I'll be around. So if you have questions, tweet me, hit me up in the DevSecCon chat. And thank you so much for the time, everyone. Adios.
Thank you so much, Randall. It was amazing. People were totally smitten by it. And there are questions. I would let Shilpi take the question, which is a wonderful one.
Yeah, definitely. Thank you so much. That was awesome. We've got some amazing content. People have taken a lot from it, and everyone's loving your slides as well. And I think Vandana and I totally agree. We might not get time to address all the questions, but there's one that I particularly want to know, and I think it's come from Muni, and it's like, what quote would you like on your hacker hoodie?
What code would I like on my hacker hoodie? Maybe like something like a seg fault or like something like that, just to represent like all the things I've screwed up. That would actually be pretty cool. But I'm also a Pythonista, and so also just any Python code really would be awesome. I really like that too. But great question.
Amazing. Yeah. So if anyone wants to sell Randall a hoodie, you know what to print on it.
I will wear it for sure if you send me one.
Amazing. Thank you so much for that and for jumping on as well. I'm sure everyone enjoyed it, and I'm glad we had those extra 15 minutes to actually go through it, because I was thinking we might have to have part B. It's like a suspense movie. You've had the first half, and it's like, what comes next? So
sorry for running over everyone.
So
No, it was great. It was great.
Right,
we loved it. We totally loved it.
Well, thank you for having me, and have a nice night.
Thank you so much.
Thank you. Take care. Good night.